Hello, children. How are you all? Okay, we will start another topic here, that is reflection of light at different surfaces. Reflection of light at different surfaces. In this, already we discussed what is a reflection. Already mentioned in different previous lectures that bouncing back of light. Okay, bouncing back of a light ray, that we are calling it as a reflection. And we also discussed why the reflected ray choose the least time to reflect back. The light ray always prefers to travel in which direction it travels, so that it will take a least time. In that direction only the light ray prefers to travel there. That was explained by Fermat's principle. Okay, in this class we discussed the reflection of light at different surfaces. Before that, we have to explain laws of reflection. Already you know in lower classes what is a laws of reflection. Suppose you consider a surface. This we are calling it as a reflecting surface. Okay, this is a reflecting surface. And suppose if a light ray is incident on a surface like this, and this ray we are calling it as incident ray. Okay, ఈ రేని మనం ఇన్సిడెంట్ రే అంటాం. And if you want to find out the direct angle, how much angle this ray is incident, for that we have to draw a normal joining the point of incidence. Okay, joining the points of incident as well as a reflection. That's why this we are calling it as a normal. This is a normal point, and this is a normal line, and this is a normal point where incident ray and a reflected ray and normal lie in the plane. This we are calling it as a normal. And this angle, where the angle between incident and normal, and this angle we are calling it as angle of incidence. Angle of incidence. Angle of incidence means the angle between incident and normal. Okay, after that it will be reflected back from the surface, and this ray we are calling it as a reflected ray. This ray we are calling it as a reflected ray. We can write here reflected ray. Reflected ray. And this one is incident ray. Incident ray. And this angle we are calling it as angle of reflection, where the angle between normal and reflected. For that, what are the laws? We have two laws are there, and we will explain there. The first law we explain here, it is the laws of reflection. In this laws of reflection, the first law is angle of incidence. Angle of incidence is equal to angle of reflection. Angle of reflection. Angle of incidence is equal to angle of reflection, where we can write angle I must be equal to angle R. Angle I must be equal to angle R. And this we are calling it as laws of reflection. First law of reflection. That means, suppose if it is 30 degrees, then angle of reflection is also 30 degrees. The why this angle, if it is 30, angle of reflection is also 30. That was already explained by Fermat principle. Fermat principle says that whenever the light ray is touching the surface, after that it tries to travel the path where it takes the least time. It takes the least time. One thing I will explain here. Suppose if the ray is incident, means there will be some incident energy is there. because light is energy. When the light ray is incident means there will be some energy is there, and this incident energy and reflected energy, if these two are almost equal, because when it touches the surface, then naturally it will some energy is wasted after reflection here. Suppose here we have some 100% of energy, incident energy is incidenting there and touching the surface and reflecting some energy. Here almost nearly equal to 100% of energy is reflecting back only when the angles are equal. When the angles are equal, sorry. Because when, suppose in different cases, in some other cases, the angle of incident and angle of reflection may not be equal. That is when we observe in irregular reflection. The irregular reflection lo manaku both energies almost same undavu, because incident energy and reflected energy, there will be some slight difference is there. But whereas in this case, incident energy and reflected energy almost both are equal. Only the case here it is because of Fermat principle. Because of Fermat principle only it is possible, where the incident energy as well as reflected energy both are almost same. Both are almost same. A small amount of energy is wasted here at this reflecting surface. Okay, this is about first law. And what about second law? What about second law? Second law, how we can say that? Second law says that this incident ray, okay, this is what we have, incident ray, incident ray, incident ray, you observe this is what we have, incident ray, and the normal, you can also see the normal, this is a normal line, this is also normal to the mirror, normal to the mirror, normal to the mirror at the point of incidence, 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 you also observe here, and the reflected ray, and the reflected ray. Have you seen these three? Incident ray, normal to the point of incidence, and reflected ray. And reflected ray all lie in the same plane, all lie in the same plane. This is what we have laws of reflection. And suppose here we have incident ray, and this is what we have normal, and this one is reflected ray. Like this we have, these three are lying in the same plane, these three are lying in the same plane. Suppose if this is what we have, a plane surface, this is a plane surface. If you assume this, then these three you can see here like this, incident ray, normal, and this one, these three are lying in this plane. Okay, this is what we have, laws of reflection, laws of reflection. Okay, what is the laws of reflection? Anguli must be equal to angular, incident ray, reflected ray, normal, these three are lying in a same plane, and here the angle of incidence must be equal to angle of reflection. Means if both are equal, then only we can have same energy, incident energy and reflected energy must be almost equal, because the basic property of a light is light always prefers to travel the path where it takes the least time, where it takes the least time. Okay, this is what we have, laws of reflection. Okay, this is about plane surface. Almost we have a plane surface here. In the next case, in the next topic here, we explain about the next topic here, we can observe curved surfaces, spherical surfaces. What about spherical surfaces and how we can assume? Here we have to explain here. Okay, next we have to explain what are different types of surfaces. What are different types of surfaces? Okay, we have two types of mirrors. that we are calling it as spherical mirrors. Okay, spherical mirrors. In the spherical mirrors, we have two types of mirrors. One is concave mirror, and another one convex mirror. Like this, we have two types of mirrors. One is concave, another one is convex mirror. What is a concave and what is a convex? Concave mirror is a mirror in which reflection of light takes place inside and the polishing of the surface is outside. And this concave mirror can also be called as a convergent mirror. It is also called as a convergent mirror. And what about convex mirror? Convex mirror is also a mirror in which polishing is inside, reflection is outside. And here this convex mirror can also be called as a divergent mirror. Like this, we have some differences. We will explain by taking the diagrams here. Okay, first we will explain by drawing the differences between convex and concave. Because you know that these two are, their differences also important here. One is concave mirror, and another one convex mirror, like this. Okay, in this concave and convex, we have to draw some differences. Okay, differences of convex and concave mirrors. Differences of convex and concave mirrors. Concave mirror. Another one is convex mirror. Like this, we have two types. We will write the differences here. The first difference, like this we will draw here. What is the first difference here? Like this, concave mirror is a spherical mirror. Concave mirror is a spherical mirror whose reflecting surface is behind, what we can say, whose reflecting surface is towards the center of curvature. And same convex mirror is a spherical mirror whose reflecting surface is away from the center of curvature. That is what we have explained here. First, we have to draw a concave and a convex. What is a concave? Concave means like this, where we can say that the reflection of light, this is what we have polishing outside. Okay, this is what we have polishing outside, and here we have pole, and this we can call it as center of curvature. Pole and center of curvature. Suppose when a light ray is there, when a light ray is incident like this, it will reflect and finally it falls at focus like this. It falls at focus. Suppose another ray is there like this. After reflection, it will meet at this point. That's why all the rays after reflection, it will meet at one point. It will converge at one point. That's why we can call it as a convergent mirror. Okay, then manam convergent mirror. Next, in this case, what about convex mirror? Convex mirror, we will draw like this. Like this we will draw here. This is what we have, convex, where polishing is inside. Polishing is inside. Okay, and like this we have principal axis, pole, and this is what we have, center of curvature. Here what is saying that convex mirror is a mirror whose reflecting surface is away from the surface, away from the center of curvature. This is what we have, center of curvature C. Okay, suppose when a light ray is there like this, when a light ray is traveling like this, when a light ray is incident on this surface, what happens here? It appears to be coming from this point. Okay, this is what we have, focus. This is what we have, focus, and this one is center of curvature. Like this we can take. Okay, suppose if you take another ray, after reflection, after touching the surface, it reflecting back. How these there? The rays after reflection, they appears to come from this point, come from this point. That's why these rays, this mirror, this type of mirror, we are calling it as a divergent mirror. Okay, that also we can write here. This is first case. What about second one? The focus is inside the mirror or lies behind it. Okay, lies inside the mirror, that also we can write here. The focus, can I tell this one first and second? Okay, first and second we can write here. The focus lies in front of the mirror. In front of the mirror. Okay, the focus lies in front of the mirror. Here, behind the mirror, the focus lies behind the mirror. Behind the mirror. And here, concave mirror is a convergent mirror. It is a convergent mirror. It is a convergent. Why we can call it as a convergent? Because all the rays after reflection, it will converge, means meeting at one point. And this one, it is a divergent mirror. It is a divergent mirror. Okay, like this we can write here. Okay, first all of you write this one. All of you write, it is a convergent mirror and this one is a divergent mirror. Okay. Last one, concave mirror concave mirror forms different types of images, different types of images, different types of images at different positions of the object, different positions of the object, different positions of the object. Okay, completed. And last here also, convex mirror, convex mirror forms virtual erected and diminished, virtual erected and diminished image. Okay, whereas in the case of convex mirror, it always forms virtual erected and diminished image, but here in the case of concave mirror, it can form different types of images at different positions of the object. Okay, this is what we have, the differences between concave mirror and convex mirror. In the next class, we have discuss real image and virtual image differences and some small definitions of all the parameters of a spherical mirrors. Okay, thank you.